want to talk to you guys about tonight is probably the one concept that sets apart, in my opinion, real photographers from people who just push buttons. And that is, real photographers have a real solid understanding of what light is and how it behaves. So we're going to have a conversation tonight on the physics of visible light. And we're going to talk tonight about how we can capture light, how we can manipulate it, distort it in some cases. So that's what our discussion is going to be on tonight. So let me go ahead and open up our PowerPoint presentation. Now, if the majority of the lectures that I'll do this semester, I have PowerPoint presentations that kind of go along with what I'm talking about. If you want copies of these presentations, you can simply send me an email. I'll respond back, and I'll give you links to these presentations. So if you don't want to take the time to write everything down in the slide, that's fine. Just send me an email. I'll respond back and give you the presentation. The presentations are too large to upload to Canvas, but I can give you a Google Slides link to it. All right, so let's talk about light. All right, so we're going to talk about tonight light and color. All right, first of all, let's just talk about the term photograph. The root of the word. Photograph is a Greek word, actually. It comes from the term photo, which is Greek for light, and graph, which is to write with or paint with. So literally, the term photography means to write with or paint with light. So photography means to write with light. So if you're going to be a good photographer, if your job is to paint with light, you should have a good understanding of what light is, if that is what you're supposed to be manipulating as part of your job. So now, if I were to use, if I were just to throw out the word radiation, right? Just think about that word for a moment. Radiation. What feeling does the word radiation give you when I first say that? When I say radiation, do you get a warm, fuzzy feeling, or is it more of a negative feeling, that word radiation? Usually negative, right? In fact, when I use the word radiation, what sort of things do you think about?
Cancer.
Cancer, that comes up, absolutely. What else? Radiation, what comes up? X-rays, sure. What else? Microwaves, certainly. What's that? Atomic energy. You know what I think about? I think about like Fukushima, right? Fukushima was the nuclear power plant in Japan that when the tsunami hit, right, the power plant melted down, and now they have these huge areas of Japan that are uninhabitable, right, because of the radiation that has contaminated that area. So typically when we use the term radiation, it's not uncommon for us to associate it with negative things. Now, what if I were to tell you that, or rather, what if I were to offer you, right? What if I were to say to you, I will give you $1,000 if you walk into that room next door that's full of radiation? Would you take the $1,000? Would you do it? Would you walk into the room and take my $1,000? Okay, so I'm hearing no, I'm hearing yes, and I'm also hearing I want more information. All right? What more information would you want, Joanna? What type of radiation? That's a good question to ask. What's that? How long? Actually, that's a good question to ask too, because the type of radiation might be harmful depending upon how much of it you're exposed to. But I think before I would take that $1,000 and walk into that room, I would want some questions answered first. And some of those questions you guys brought up. What type of radiation is in that room? Because in actuality, the room that you're sitting in right now is full of radiation. Because visible light, which is what's coming out of these lamps overhead, visible light is simply one form of radiation. It's not harmful to us. We can see it. It doesn't give us cancer. It doesn't kill fish. It doesn't turn us into the Incredible Hulk. But there are other types of radiation out there which can be extremely dangerous, which can kill us even if we're only exposed to them for a moment. Right? So it's important then that we understand what radiation is. Right? So, what is light? Visible light is electromagnetic radiation. So visible light is simply one form of what we call EM radiation, electromagnetic radiation. Now, light is interesting. Light consists of bundles of energy, packets of energy, which we call photons. But when that energy travels, when it travels across from one place to another, it travels in the form of a wave. So light acts as both a particle in the form of a photon. But when it moves, it travels in the form of a wave. We're going to think of light more in its wave-like manner when we talk about it in the talk. Now, visible light is a very, very small portion of the overall spectrum of the different types of radiation out there. In fact, there's other radiations out there. In fact, you guys named some of them. When I asked you, what do you think of when you think of radiation? You guys actually named some of them, right? I heard someone say X-rays, and I heard another person say microwaves, right? There's other types of radiation out there besides visible light. Let's see if we can name some. In fact, one of the very likely test questions on your midterm might be to name 4 or 5 forms of radiation. All right? So let's name some of them. Gamma is a good one. We're going to talk about gamma in a moment. I'm going to break these down in a little bit, but gamma radiation is a good one. Infrared radiation is a good one. Ultraviolet radiation. By the way, infrared, oftentimes abbreviated just IR. Ultraviolet, oftentimes abbreviated UV. Sure. Unless I ask on the test, what does IR stand for? Radio waves. That's another one. Exactly right. What are the, you guys listed some before, right? They were X-ray radiation. That's not a type of radiation. It's a grouping of radiation.
What was that?
Short waves. You guys mentioned earlier microwave radiation. That's part of radio. It's part of TV is part of radio or broadcast. So when we say radio, we're not just talking about radio waves in terms of audio that comes from a radio antenna from your local radio station. Radio waves include all broadcasts, so that's both television and radio. Your cell phone uses radio waves, actually. Yes?
Is that why a lot of times when there are antennas involved, they have danger signs around because of the radiation?
Well, any type of radiation technically could be dangerous, and we'll talk about why that is in a second. That's a good question, Ron, and hopefully I will deal with that. Some radiation substantially more dangerous than others, but all radiation in large enough doses could be dangerous. Let's see, any ones we're forgetting? There are a few. All right, cosmic radiation. Cosmic radiation is one we're missing. I think that's it. Let's see, cosmic, gamma, X-rays. All right, we got visible light, UV, infrared, microwave, and radio. I think that's it. All right, so let's talk about these different types of radiation. Cosmic radiation. Cosmic radiation. Yes, question.
Are those also go with the words that we spoke last week? Yes.
Yes. Yeah. All right. Now, of all these different types of radiation that are out there, some of which are very harmful. Cosmic radiation, extremely, extremely harmful. If you're exposed to even small amounts of cosmic radiation, it's likely to kill you. some of which is not harmful at all. Radio waves are not harmful. How do I know that? I know that because your cell phone emits radio waves. And if it was harmful, do you think you'd hold it up next to your head and talk on it? If it was, because it does emit radiation. When you're talking on your cell phone, it is emitting radiation.
Is that what they say that?
There are people who will claim that. Now, interestingly enough, there has been a correlation between some people developing certain types of cancer and where they store their cell phones. My wife, for example, has her cell phone. Guess where she stores it a lot? Besides in her pocket. She'll put it right here under her bra strap. Exactly right. And there have been some studies that have showed a correlation between certain types of breast cancer and the fact that some of those women have actually stored their cell phone right near that area on their bodies. Now remember, cell phones emit radio waves. Now radio waves are not normally cancer causing. And I'll explain why in a little bit. But if you keep it there 16 hours a day, every day, and it's constantly producing radio waves, guess what? There could be some mutation as a result. Right? Who's here got an x-ray in the last, I don't know, year and a half, 2 years, all right? When you got your x-ray, the person doing the x-ray, the radiologist, or the x-ray tech who took the x-ray, what did they do before they pushed the button to take the x-ray? They walked out of the room, right? They probably did not stay in there. That's what happened to me too, right? I'm there, I'm getting x-rays of my teeth, and I'm sitting there in a chair, and what do they do, by the way, before they take the x-ray? They put a big lead vest on your chest, and then they walk out of the room before they turn that x-ray on. Why is it? Because x-rays can be harmful. Now, getting 1 or 2 x-rays is not likely to get me cancer. But if I'm exposed to x-rays time and time and time again, that large dose of x-ray radiation increases my risk of developing cancer. So the x-ray tech doesn't want to stand there in the room and get exposed to x-ray radiation, so they leave the room. So it's not just a matter of the type of radiation you're being exposed to, but also the duration of exposure. Which is why I'm just suggesting, folks, if you do have your cell phone, maybe you try to store it in your pocket. All right, maybe even switch the pockets, I don't know. Anyway, what makes one form of radiation more harmful than another? It's important to understand the difference between the different types of radiation. Of all the different types of radiation out there, what is the only one that we as humans can actually see? Light, visible light. Of all the different types of radiation out there, and we listed them all, right? Cosmic, gamma, X-rays, microwaves. Of all the different types of radiation out there, the only kind of radiation we can actually see is visible light. Remember I said before, you're sitting in the classroom right now, you're in a room full of radiation, because what sort of radiation is in this room? Visible light. You can see it. If there was another form of radiation in this room, let's say gamma radiation, could you see it? No, you'd have no idea it was there. You couldn't see it at all. And the bad thing is gamma radiation is very harmful. So if you were to walk into a room and it's full of gamma radiation, you have no idea it was there, and if you stood there long enough, you would be dead. Or if you eventually left, if you were exposed to enough of it, now you've developed chronic cancer, and you're going to die within maybe a couple of months or maybe a year. Right? And you can't see it. You cannot see gamma radiation. You'd have no idea it was there. The only type of radiation you can see is visible light. So let's talk about the difference between the different types of radiation.